So after speaking about the cirrus clouds, now let's talk about the low clouds and how they impact the climate due to this radiation balance. So the low clouds also have an effect on both the incoming sunlight and also the outgoing long-wave radiation. First of all, when you look from space or from above at these clouds in the bottom right, you can see that they're very white in color, and actually we cannot see the ocean through this image. You can see the little hole where we have an island there. The ocean is very dark, even black in the background, but these clouds are very white and are made out of water droplets, unlike the cirrus clouds, which are ice. And so these actually, because of their color, reflect a lot of the sunlight back to space. So these have a much higher albedo effect than the trapping in of the heat. And the reason that they don't have such a large effect for the heat trapping is because the emission of energy out to space, as we've mentioned a few times, is related simply to the temperature to the fourth power. Now these clouds, the low clouds, are fairly close to the surface. So the temperature difference between the surface, if it's the oceans or the land, and the clouds, which are maybe a few hundred meters or a kilometer above it, are not that different. So the clouds do absorb a lot of the infrared radiation, the yellow arrows here, but they re-emit this radiation at a slightly cooler temperature, but nothing like the cirrus clouds, which are maybe at 10 to 15 kilometers altitude in the tropics. So these clouds, the low clouds, have a very high albedo effect, a cooling effect on the climate, but they have less of an effect of the warming and the greenhouse effect. And so overall, the net effect of the low clouds is to produce a cooling of the planet. This actually depends on what is in the background underneath these clouds. These clouds normally are over the oceans, but consider what would happen if these clouds were over ice, over an ice sheet, over Greenland, or over snow. Then the difference won't be so big, because whether the clouds are there or not, they don't have such a big effect on the albedo, because the snow is also white, or the ice is white, and would also be reflecting the sunlight. But when these clouds are over the very dark oceans or very dark forests, then they have a much larger effect on the albedo, less effect on the greenhouse effect. Overall, these clouds have a cooling effect on the planet. Now again, we mentioned if we change the altitude of the clouds, they will re-emit the energy at a higher altitude, which is a cooler temperature. So if we raise these clouds, even the low clouds, they'll have less of a cooling effect with time. If the climate change results in these low clouds actually rising up in altitude, then we'll decrease this cooling effect. So we don't know, again, what's going to happen. We don't know what the models aren't that good to tell us how the low clouds, how the high clouds are going to change. But if they do change in altitude and get higher up, then they'll have less of a cooling effect compared with what they had in the past. Where are these clouds found on the planet, the low clouds? So here again, we see in the blue color where we have the highest frequency of occurrence of these low clouds, and we can see it's very different to where we saw the cirrus clouds. These clouds are mainly over the oceans and mainly over the cold ocean currents, like off the coast, the west coast of South America, Peru, Ecuador, off the California coast, off Namibia, off Western Australia, the Canary Islands. Where we have the cold water, this is the region where we also have these very low clouds, which are actually covering and masking the dark oceans and resulting in a very white region, which reflects again the sunlight back to space, traps in the heat but re-emits it, and overall we have this cooling effect here over the oceans in the blue regions. So where the clouds are actually cooling the climate and where they're warming the climate are in different regions on the planet. And so we have to know how these areas are going to respond to changes in greenhouse gases in order to understand how clouds may change in the future, and therefore may change the radiation balance of the planet. When we look at the very deep convective clouds, or what we call thunderstorms, or the cumulonimbus clouds, these are very deep and thick clouds, and actually they reflect most of the incoming light. You can see the red arrows. Basically everything hitting the top will be scattered out, and we have a very high albedo effect. But on the other side, all of the heat which is given off from the Earth underneath these storms will also be trapped and remain in the system, some of it re-emitted. And so these two effects are very large, but they balance each other. So we have a cooling effect on the top, a warming effect at the bottom, but when we put them together, the cumulonimbus, the thunderstorm clouds, the deep convective clouds, overall they have neither a warming nor a cooling effect, so they don't really affect the temperature of the Earth by themselves. When you separate them into high clouds and low clouds, they do have an effect, but when you put them together in these deep thunderstorms, and you can see an image at the bottom right taken from space with these clouds which reach maybe 20 kilometers and then spread out with these large ice anvils, overall they don't have a warming or a cooling effect on the climate. So to summarize the effect on the climate from clouds, it's basically the high clouds and the low clouds. The high clouds, which are these wispy ice clouds, they let most of the sunlight penetrate through, coming to the surface, but the heat which is given off in the red arrows from the Earth, most of this gets trapped in by these clouds like a blanket on the Earth, and on the left these high clouds have a net warming effect on the planet's temperature. On the right-hand side, the low clouds, which are mainly water droplets, they reflect a lot of the sunlight, most of the sunlight, having a cooling effect. They also trap in a lot of the heat, but because these clouds are very low and close to the surface, the clouds re-emit this energy out to space, and when we put these two effects together, the low clouds generally have a cooling effect on the temperature. Now, if we look at some numbers from satellite data, looking at what we call the cloud radiative forcing, both the albedo forcing and the greenhouse forcing. So this is looking just for a few months in 1985. We can see that the long wave forcing, how much extra energy or how much energy is added or taken away from the system because of clouds. The long wave cloud forcing we can see is around about 30, 31, 32 watts per square meter. That means because we have clouds on the Earth, we are trapping in an additional 30, 32 watts per square meter. We're increasing the amount of energy. But if we look at the shortwave forcing, these are negative numbers, minus 45, minus 50, minus 51, which means we're losing 50 to 51 watts per square meter because of the albedo effect, because we're reflecting the sunlight back to space. When we put these numbers together, we see that the negative shortwave cloud forcing is larger than the long wave cloud forcing, and the net cloud forcing is around about minus 13, minus 21. On average for the annual mean, around about minus 17 watts per square meter. This means that because we have clouds on planet Earth, we're losing about 17 watts per square meter all the time because of this more reflection of energy than the trapping in of the energy. And so overall clouds, because it's a negative number, cool the climate. And as a rule of thumb, a 1 degree watt per square meter, you can say, is more or less a 1 degree warming or cooling. And so this means that the clouds on planet Earth actually cool the temperature by close to 20 degrees, just because they exist in our atmosphere. And so basically, without clouds on planet Earth, the temperature should be maybe 35 degrees centigrade and not 15 degrees as it is today. The clouds have this cooling effect. Overall, they have both the warming and the cooling, but overall, we see that the clouds cool the planet by around about 20 degrees. And now with climate change, we're talking about a warming of 1-2 degrees in the future. If we change clouds just a little bit, we can either double that warming or we can get rid of that warming. And a lot of research is being done around clouds because clouds have such an important role on the climate, and we really don't know what's going to happen to clouds in the future as the climate changes.